Multi-part problem, we're going to be taking composites of f of x and g of x, and then finding the domain of each composite. So for part A, we are looking for f of g of x. So I'm going to start by rewriting f, but instead of writing f of x, I'm going to write f of blank. So everywhere in this problem where there was an x, I'm just putting a blank. Inside that blank, we want to put g of x. And g of x is equal to the square root of 2 minus x. So if we simplify this a little bit and get rid of some of these parentheses, we end up with 5 radical 2 minus x plus 1, which cannot be further simplified. Now for part A, we want to find the domain of this function, and they want us to write our answer in set notation. So whenever we're looking for the domain of a function, there are two types of expressions that we have to pay particular attention to. Fractions, because denominators cannot equal 0, and roots, because roots cannot be negative. So in this example, we only have a root, so we take this piece of our function and we say, okay, well, 2 minus x cannot be negative, meaning 2 minus x has to be greater than or equal to 0. And that is how we're going to restrict our domain. So in order to solve for x here, we're going to subtract 2 from both sides. Negative x is greater than or equal to negative 2. And then we have to divide both sides by negative 1. And there's an important rule. Whenever you divide an inequality by a negative, it reverses the inequality. So be careful with little things like this. It'll change your answer. We end up with positive x and positive 2, but our inequality sign has to flip in the other direction. So we end up with x is less than or equal to 2. So that is our domain. We just write it in set notation now, x such that x is less than or equal to 2, and that's our answer for the second part of A. Okay, now on to B. In part B, they want us to find g of f of x. So we're going to start by rewriting g, but we're going to leave a blank anywhere there was an x. So we have the square root of 2 minus blank. And since we're plugging f of x into g, we're going to put f of x right in this blank, and f of x, which is 5x plus 1, right into this blank. Now let's simplify. The square root of 2 minus 5x minus 1, we just distribute that negative sign, becomes negative 5x plus 1 when I combine the positive 2 and the negative 1. To find the domain here, again, we're just looking at a root. And as we discussed, roots always have to be greater than or equal to 0 because they can't be negative. So I'll rewrite negative 5x plus 1 greater than or equal to 0, and let's solve for x. Subtract 1 from both sides, and then divide both sides by negative 5. And I'll put another little asterisk here to remind you that since we're dividing by a negative, it reverses our inequality. So we get an x and a positive 1/5, but this time our symbol has to flip, and we get x is less than or equal to 1/5. They want us to write this in set notation as well. I don't know what this drop-down menu contains because I'm not looking at the actual problem. I'm looking at a screenshot of it, and I can't pull the drop-down menu down. I think they might have left some things out that should be here. But if we're writing this in set notation, we just do all x such that x is less than or equal to 1/5, put our brackets around it, and there's our domain for the second part of B. Moving on to C, they ask us to find f of x. So we start with f, the one on the outside, and we're rewriting f, but leaving our x's blank. So instead of 5x plus 1, we write 5 blank plus 1, and inside that blank, we're going to put f of x, which is just 5x plus 1. Now let's simplify. We'll multiply the 5 through the parentheses, and then we will combine the 5 plus 1. To find the domain of a function, we only need to look at if we have denominators and if we have roots. Here, we don't have denominators or roots, so our domain is all real numbers and there are no restrictions. And in this example, let me scroll up just a little bit, they want us to write our answer in interval notation. You can tell because of the parentheses with the comma in the middle, this is interval notation. So we would just write negative infinity to positive infinity, and that's our domain for part C.